So for lesson 7.2, we will continue our discussion of random variables, this time with a continuous random variable. Now, a continuous random variable has an infinite number of possible values over an interval. An example of this would be all real numbers between 2 and 3. There's an infinite number of numbers between those two numbers. Okay. So there's a couple things here we need to remember. First of all, total area under the curve must be 1. Has to be exactly 1, not kind of like 1, but exactly 1. We talked about this when we talked about normal distributions. So we should remember that area under any single point is equal to 0. And then the third one is a reminder that probability of an event is the area under the curve between the values that make up that event. And I have an example that we'll go over in a minute with this. So take some notes on this, and I'll pause the video for a second for you. Okay, so let's talk about one of the continuous distributions. It's a uniform distribution. The curve is usually a square or rectangle. In fact, since it's uniform, it's always going to be a square or rectangle because the probability is always going to be the same. And let me show you an example of this. So we have a curve here. Let's say it's 5 long. That means the height here must be 0.2. 0.2 times 5 is 1. And we want to know what the probability is of picking a number between 2 and 4. So we want this area in here. So the way we would find that is we'd say, okay, the length of this is 2. We know that because 4 minus 2 is 2. Times 0.2 is 0.4. So the probability of picking a number between 2 and 4 is 0.4. And here's my reminder. Probability is just area under the curve. Find the area. That's it. A normal distribution. So this is a continuous distribution that we have seen before. And a normal is defined here, in general, as mean and standard deviations. Mean and standard deviation. And a z is equal to x minus mu over sigma. So it's x, whatever value we're testing, minus the mean over sigma. And let's take a quick look and see what z does. Z changes things from a normal with a mean mu, standard deviation sigma, to a mean of 0 and a standard deviation of 1. And this is what allows us to use our z tables. So that is continuous distributions. It shouldn't be that bad. Just make sure you take some notes and ask any questions you got. Thank you.